So everybody understand? Is it?
Mr. Lim, I got a question.
Marvin, okay, you are, where are you from? Sorry, I don't know you.
Okay, I'm a structural engineer working in DP Engineers.
In where?
DP Engineers, DPE, under DP Architects.
Oh, DP Engineers, okay. Okay, come,
Yep.
DP Engineers, yeah.
Okay, so actually my question was, you mentioned about the competence stratum, right? Because just now your explanation got cut short because we have no time, but I just want to get an idea. So how do you actually determine the competence stratum to terminate the pile boring or driving? Is it by the RQD, like the rock quality destination? Is it like one way we can determine that we can be sure that, okay, we can terminate the piling here?
It's a very good question, Marvin.
Yeah, all right.
You can ask this question means you face this problem on site, right?
Yes, that's right. Contractually also, yeah.
You only know my CV. You don't know what I work for. I work for builder, I work for consultant, I work for authority, I work for powering contractor before. So I actually see from 4 angles or 4 perspectives of different people. Okay?
Okay.
Now, have you supervised a ball pile before, Ravi?
Yes, yes, I did.
So you are RTO or RE trained, right?
I have a RE cert.
No, have you worked actually as an RE before on site?
Yes.
Doing supervising ball pile foundation?
Yeah, like doing a standing supervision, like seeing how it's done.
Yeah, but you know when you, hey, I take this opportunity to educate all the IRTO here. You are paid to supervise, no? You are not paid to witness. You know what is the difference between supervision and witness? Supervising means you need to check against a certain criteria for the performance or the quality of the work. Witness means I only see you do. Whether you do it correctly or not correctly is not my problem. You see the point here? A lot of clients engage project engineers. Actually, their role is to witness. But your role is to supervise. So you tell me you actually do standing supervision on the ball pile. Is it in a rock foundation? Is it in rock or in soil? Marvin?
It's in a soil condition.
So you never encountered rock before, right?
Okay, when I encountered, I don't do supervision. I was standing by just to witness.
No, but the same question I posed just now. Instead of soil, I now ask you, sorry, Calvin, I have to use you again, Calvin. Calvin, the ball pile contractor. They reach, they ball. Then they hear kong. The machine keep start to shaking, you know, the computer is shaking. So the operator informed Calvin, say, hey, boss, we hit the rock already. Then Calvin come and tell you, Marvin, hey, RE, come, we reach the rock. Hey, can you come and witness, is this the rock the designer want? How will you answer this question? Marvin? Today you from RE to office. Yeah. Now you also do design. You also have some experience. Now I'm asking you, how you answer this question? Calvin come and tell you now, hey, we reached the rock. Hey, can you come and confirm, is this the rock that you want to socket in?
I think more experienced geotech engineer, when they come to site, they would know it's rock. But I'm not that experienced yet, so I will ask them to prove that it's really rock by carrying out a rock quality destination test.
Okay, hey, you answer like that, huh? If today you go for P interview, if I interview you, you will fail. Okay? If today you happen in the legal case, you go to court, you also will be prosecuted. Because once you register yourself as RE, you cannot say that, hey, I'm not a geotechnical, so I cannot confirm. I get a geotechnical engineer to come and confirm the rock. This is wrong, This is wrong. DP engineer, huh? There's another lady from DP engineer. Is it Joanne or Jasmine? Left already. Intern. Last minute then. Joanne, is it? Joanne, are you here? Joanne. Joanne, are you here? Okay, never mind. So, you come here and tell me, you say you cannot confirm this rock. Then can you say, if you cannot confirm the rock, who can confirm the rock? What's your answer? Marvin?
Yeah. I'm not sure. That's why I asked. That's why I asked. I'm not sure, seriously.
No, you must put yourself in a real life situation. It is maybe 10 o'clock at night. Your QP don't answer your call. You on site, they pressure you to tell him whether we can start counting. What is your response? What is your response? Just imagine you are now in this situation. What is your response? Hey, for all of you who are listening here, this is a very real life situation. In my 20-year of career, numerous people have this problem. Until now, nobody. Actually, there's a solution. But many people somehow don't want or don't know to follow this approach to solve the problem. Now, you are a designer now. Now I change your role. Let's say you design for a rod socketed pile. What kind of rod you want to design?
It can be G3 or G2, depending on the design, the preference of the engineer.
Sorry?
If it is a Bukit Timah granite, then it may be like, let's say, G2 rock formation.
Okay, in your SI report, let's say you got many boreholes, okay? I give you a scenario, Marvin. I give you a scenario. There's different, you have 10 boreholes. Every borehole show rock, okay? But the rock vary from G3 rock to G2 rock to G1 rock. When you design time, what is your rock that you want? Where will you design? You will base your design based on G1, G2, or G3. I give you some time to think. Let me talk to somebody in the chat group very eager to answer this question. My friend, Kelvin from Melbourne. Kelvin, I let you talk now, Kelvin. Hey, not your baby talk, Kelvin.
Yeah, I've got 2 kids in front of me, so I can't reply. It's really late here, so I can't really talk.
Oh, I see.
Yeah, sorry about that.
No problem. Who else? Okay. I asked another P. Engineer Anthony Tan. Now today you are his QP. How you can help Marvin to solve his problem on site now?
Hi, Engineer Lim. Thanks for giving me the opportunity to actually share my experience.
Can you speak a bit louder, Anthony? We can't hear you. Yeah.
Can you hear me?
Slightly louder, yes. Better than just now, yes.
Okay, thank you for opportunity for giving me some to share my experience.
Thank you.
Okay, so in order for the question is asking, do we need to actually supervise whether contractor has said they have reached the rock?
Yes.
So asking us to go site to supervise it.
Okay, the question is like that. The piling contractor already reached the competence short term, okay, the top of the competence short term, and they need to start to calculate the socketing length.
Oh, okay.
Okay, so they call for the RE to come to confirm this is a competence short term.
Okay. Competence stratum, let's say you're talking about SPT N values.
No, he's talking about rock.
Rock, okay, fine. Let's say based on SPT N value, we actually on site also, on one of my projects, just sharing SPT 100. the consultant has designed SPT 100, and we have actually reverted to them that there's no way for us to justify on site that it has reached the SPT 100, because when the spoil just came out, you can't justify the stiffness of soil. Then you can't correlate to the blow counts and the stiffness of soft, loose, or and soft, firm. I mean, hard. Or this. If rock, yes, possible. Rock, I mean, depends. Let's say it's coring, the rock samples come out is big enough. Then you can use a Smith hammer to knock it lah. Whether it's you want it G4, G3, or G2, yeah. First of all, you see weathering, the weathering, and then the next part is to use the Smith hammer. Let's say it's large enough, you can knock it and see whether the sound, you can hear the sound.
Okay.
And then see whether G3, G4, the other properties is we are talking about is slates in the water. That's something is sidetrack a bit like. Let's say you are, I mean, you are keen to know more, then you can go for that. Otherwise, if let's say the rocks came out is very much fragmented, then you can see whether the fragments rocks that came out, you can see whether is very much angular or it's already been weathered. If let's say is weathered rock come out, it's like very sandy type, then it's very roundish because it has been really weathered. If let's say those are very angular, you can feel the very sharp angulars those are due to the coring, which come out is very sharp. So you can feel that it's hard. It's hard rock already. You have reached a G3 rock. I would put it this way. If let's say it's very spoiled, it's very much spoiled, then next thing you just check whether there's a soft toe. That's how actually I would maybe go by this way.
Okay, thanks for your sharing. Anthony is sharing from his experience, okay? And you notice that everybody experience is different. And somehow that we do not have a so-called logical and so-called quantifiable approach on this issue. In fact, if you understand, okay, let's start, Marvin. Let me solve your first problem first, okay? Let me solve your first problem. I send you all the guideline. I'm not sure whether you all see it. Let me open this guideline for you all first. New share is, okay. Okay, all of you can see here. Now we are in this actual guideline that we refer now. The 7 criteria, right? Remember? I mentioned about the 7 criteria, right? So you can see a very new one, 2nd September last year. Now, when you I saw from the message, Mr. Sultan San, right? Mr. Sultan San, are you here? Sultan San, right? Sorry, I cannot pronounce your name properly. You mentioned, he replied a very good thing. He said, we design for the worst case. That means the worst quality of the rock, which is G3. I agree with that because that is usually what I do. Okay? Because I don't know on site whether you see is G2, G1 or G3. Okay? Whatever we encounter for rock, we do this kind of thing. Now, as you scroll down this thing, the most important thing you need to do is, of the 7 criteria, the most important criteria you need to follow is this thing, the point load index. If you recall what I tell you during the design, in rock, we design according to unconfined compressive strength. Okay? Unconfined compressive strength. And why we need to do the point load test? Because we can correlate the unconfined compressive strength with the point load test results. Okay? Usually you can see like that. Okay? Usually you can see like that. You can see this kind of correlation. You're supposed to do this correlation. So when Marvin, you must listen carefully now. Calvin, you also must listen carefully now before you all start to fighting on site. sometime in the middle of night, I receive call from my RE or RTO fighting with the powering contractor on site on this kind of issue. Usually, I will scold them because they don't understand instruction. What you need to do is, according to the new guideline, is very clear. Once the core barrel release the rock after they drill, you can go and do the point load test index on site. Okay, you can do on site. Read carefully. Point load test from rock sample from ball piles, pile balls. You can do it. You can actually do it on site, and you're supposed to do it on site. So it then go back to the first thing. In the first place, when you plan your SI, you must always plan for point load test index and also plan for unconfined compensation. Then you establish this kind of correlation. Then on site, from the power ball, you do the power load test. Okay? From the power load test, then you start to correlate to UCS, then you confirm whether that is the rock according to the design. Marvin, you understand? Marvin.
Yes, kind of. Yeah. So you correlate between UCS and the point load test, right?
Yes.
That's what you're saying.
So
okay.
So Kevin.
Yes.
Ask your boss, Mr. Pua, to go and buy one set of this kind of point load test index equipment on site. Very cheap only. Okay. Before you start any rock project, power in rock one, you ask them for this correlationship. Okay? Then on site, you test ready, correlate from the chart and tell the IRQ, we do the test ready, the test result is like that according to design. This is the design compressive strength you want. So this is a socketing length. No need to discuss, no need to argue. Everything got number to support. Clear? Clear or not?
Okay.
I hope all piling contractors follow this manner. This kind of cheap thing also don't want to invest. Every day go and argue with people on site. Waste of people's time. Correct or not? Now, second question by just now Anthony. My previous RTO answered this question. Very good. Dinesh. Where are you, Dinesh?
Yeah, hi sir. Yeah, I'm
Dinesh, you understand Anthony question just now, right?
Yeah, I understand.
If you see SPT soil, Anthony said that on site I cannot verify. You tell them how we verify on site SPT 100 soil.
Yeah, we usually collecting the samples once we reach the way stratum, especially in our current site. So we just use the penetrometer to check the strength of the sample. I mean, we take some undisturbed sample, then we just press it on it, and then we just correlate the charts with the penetrometer readings. So we get the results.
Anthony, you there? You get what I'm trying to say?
Yes. Okay. So you need to invest in some equipment to verify it on site.
That's actually very cheap only.
Very cheap, I'm telling you. And penetrometer is very, very cheap. Cheaper than your iPhone, I'm telling you.
Yeah, that's about $40-50, I guess.
Right.
So
yeah. Thanks a lot. I learned new things today.
That's good. You suppose. I'm telling you, you see here, why today this crowd is good. You all come from different aspects of the industry. Okay? And all of you here cannot avoid ball power construction and ball power design one. Cannot avoid. So I did not actually solve your question. I just let each of you start to have a dialogue and solve each other problem. You see here? Good, right? So actually you learn from each other. Okay? Very good. Any more question?
Thank you, Mr. Lim.
Kelly.
Who is that? Yo, huh?
Sorry. Yep. Yo here. How are you?
Oh, Yo,
okay,
how? Okay, Mr.
Good.
Yo is a very senior SIE, huh? Okay, come, Yo, what's your question?
Okay, no,
I forget
no
about
need for
asking you.
introduction.
I forget about you. I forget to ask you just now. Yeah, come, you ask.
No problem. Okay. Touching back on this, I think you and me previously got experience, right? Now that you say penetrometer very cheap, yes, but somehow a lot of times still unavailable on site. So my question is either contractually or legally, who is responsible when it comes to this type of crossroad or this type of uncertainty? You see, whenever there is a ballpark work, you were saying RE is fully responsible because they are the supervisor team, right? But then if you are not given a gadget whereby, contractor not willing to spend money, when you don't have this gadget, there's no way you can verify, right? Whether it's those SPT soil or whether there's a rock. So equipment is important, right? Then when without this, previously the incident is, then people will start requesting whether contractors should provide geologists, REGO, because they are experienced on this. Then they will be the party verifying this, correct? So now my main question. So my main question, with let's say with agreement that this respective staff is being employed, ultimately it should touch wood, should, if anything goes wrong. My question to you is, legally, who is responsible should something goes wrong in verifying all this without equipment?
Okay. Finish.
Yeah.
You have asked a legal question, not so much of a technical question. Agreed? Yo. So actually, you know all the right things to be carried out on site. Yeah. But now your question is, who's supposed to be responsible to pay for the penetrometer, right?
Correct.
Now, if you go and read Building Control Act, right? You go and read Building Control Act. Especially on this case study on the Church Street, why the IE was charged? Actually, the QP was not charged, Do you know that the QP was not charged? The IE was charged, but the QP was not charged. The QP simply say he follow what the IE tell him, because IE is supposed to supervise for him. Okay? So today you are engaged by a consultant to be IE or RTO, and you're supposed to, and you know there's such thing called a penetrometer, and you know you need this to do the work, but the guy, the QP who employ you is not willing to pay for it. You got two choices. Okay, you got two choices. You don't do the job. Okay, you don't do the job. You cannot say that you do the job halfway, then you know that you need to do supervise ball power, right? Before you go in, you already know you need to supervise ball power, right? This is a free market, right? You decide whether you want to take up a job or not based on the condition given to you. So the liability solely lies on you. The second option you can do is you go and buy yourself. Okay? You can go and buy yourself. Frankly speaking, this is not even an issue. For all my project, I straight away tell the plumbing contractor to go and buy one. Their contract in few million zone, he cannot buy $70, $80 penetrometer. Then you myself don't come and do plumbing contractor. Okay?
Yeah.
Answer your question. So actually this question really is not an issue. Don't think too much on it.
Okay.
I want to address.
Meaning that.
Sorry.
So meaning that whether make separate arrangement of engaging geologists, all these things may not be a good idea.
In the Building Control Act, there's no statement saying that the geologist is answerable, you know.
Okay.
It's always the
Understand.
qualified person or the qualified site supervisor, you know.
Okay,
You clear?
understand.
Okay, hey, you all
Yeah,
better go
thanks.
and read building control act carefully, you know. You don't happily assume that this is the contractor liability, is the owner responsibility, the QP responsibility, you know. You better go and read, okay? You all better go and read the building control act, okay? Any more questions? Wow, this very long already. Almost 6 o'clock already. 2 hours. Have to end soon.
Sorry to take up your time.
Last question. Any more last question?
Yali, can I ask one more question?
Who is it?
I will.
Okay.
Yeah, it's regarding the power structure design.
What
Actually,
design?
you share one power link, the structure capacity check.
Power link capacity?
Structure design of the bore power.
Structure design, yes. Then?
You share one document with us. It's the BCA guideline on power design by your code.
Yes.
It's on page 48. It is mentioned about the your code tool.
Yes.
There's one clause 5.8.9. Yeah, it mentions design of axial resistance of section NRB and the biaxial bending of RC column has been unconservatively used as the structure capacity of the bore power. My question is the clause in the your code 2 mentioned here is regarding the biaxial bending.
Okay.
But it's in the your code, this clearly mentioned the formula is the FCD times ACC plus AS times FYD.
Continue. So what's your question actually?
Okay. So my question is, does it mean this formula is wrong? You cannot use this formula in Singapore because the Yoko is adopting this formula.
Okay. You cannot say the code is wrong. You can only say that local national annex and the local authority has the power to implement a higher or more stringent requirement above the code. Okay?
National annex never mentioned about this.
No, national annex no need to mention. National annex no need to mention. As long in BCA or IES, GOSS combined advisory note to you. Just like just now I shared with you on the guideline on the rock identification. That is also not EC7. That is also not national annex. That is a BCA advisory note or BCA guideline. You understand?
Okay. So it's
So
considered
today, let's say if you do the project in other country other than Singapore, you can free to use the EC7 or EC2 to design the structural load. Okay?
Okay.
But in in local context, you cannot use because you will not get approval. And I also want to touch on this thing. Many structural engineers like to use a higher structural capacity to reduce the number of bore piles. Okay? End up, okay, because our HDB always want the high utilization ratio, meaning they want every single pile to perform almost 90% to their capacity. This end up every single pile take a very, very high load compared to last time where you limit the structure capacity to 7.5 MPa. Okay? So even today you want to use a very high concrete grade to increase, heavily enforced to increase the structure capacity. BCA will impose a lot of requirement on you such that to discourage you from doing that. That is the reason one. When you have a very high structural load, in the end, your pile will be very long. And in the end, your settlement will have an issue. Okay? So this is the underlying reason why BCA discourage people from using a high structural load capacity. I hope I answered your question.
So we are still adopting the formula from CP4 and CP65.
you adopt the formula, the what is recommended in the guideline I sent to you.
Yeah, they are talking about CP2 and CP60. Okay.
Okay.
Thanks.
Okay. Good. I think we have to stop this. What I'm going to do now, okay, since what I'm going to do now is I will try to post this video to a YouTube, okay, so that y'all can rewatch how many times you want, okay. And do me a favor, and if you want, I probably will do another part because now we're only talking this is a preliminary design. Actually, ball power designs got many other, including the load test that you're talking about, including negative hinge friction you're talking about, also talking about settlement, how you estimate settlement, and also there's a lateral power that we have not covered. So I probably will do a second part on ball power design. That is more advanced design level, which many of you may not be really necessary to know, and because you may not be doing design work, you probably is only doing the site solution work or site construction work. Okay, so I will see how. I want you all to leave your comments. Okay, I hope you all can leave your comments. I want you all to leave your comments in either you want to leave the comments on the Facebook, you want to leave the comments on the YouTube channel later on, which I'm going to share with you what is the channel. Up to you. I will try to answer your questions. So because I cannot answer all your questions, you got 100 over of you. So I'll try to answer as many questions as you want. So I think today is a good trial on the Zoom. I didn't know it can be so convenient, but a bit too long because I think there's some technical. My computer just now crashed. Okay, so good. I will stop here. I hope to see you soon again, if possible. If not, then you have my email, right? I believe you all have my email. If you have my email, then if any question, you can just email me. Yeah. Okay. Okay. Thank you. Thanks, everyone. See you again.
Thank you.
Bye bye.
Thank you. Thanks.
Thank you, Mr. Lim.
No problem.
Thank you very much. Take care. Be safe.